Howdy, howdy, folks. Once again, it is Donnie coming at you with yet another video in our storage management playlist. And today I just want to give you a quick introduction to the concept of RAID. And I especially want to focus on the aspect of using RAID technologies in order to safeguard your data in the event of a drive failure. And the first thing to know about RAID is what the term stands for. Well, it originally stood for Redundant Array of Inexpensive Disks, even though in 1987, when RAID was invented, there was really no such thing as an inexpensive disk if you look at it in absolute terms, and compared to modern standards, compared to what disks cost nowadays. But they called it that because it was designed to use commodity hard drives that were meant to go into just normal desktop personal computers. And they were inexpensive if you compared the price of them to the price of the big honking drive assemblies that went into the mainframe computers. So in that sense they were inexpensive. But anyway, over time somebody decided to change that to redundant array of independent disks. But what I really want to focus on here, though, more than anything, is this term redundant, because we want to use RAID as a way to set up these redundant disks so that if one disk fails, well, you won't lose your whole server, right? You won't lose all of your data because the other disks, or disks as the case may be, can just carry on until you replace that bad disk, or, well, bad drive in modern parlance. I don't think anybody really calls them disks anymore. They're nowadays they're called drives, but still the acronym, the D in the acronym stands for disks. Okay, so anyway, before we get into this too much, I do want to do a quick update on the story that I covered in the previous video in this playlist, only because it pertains to what we're about to talk about. And this has to do with the sad saga of the Express Crypto micro wallet service, which, of course, if you look at that previous video, I explained about what the micro wallet service is all about. But the short explanation of it for now is that they were in charge of safeguarding people's crypto funds. So they had a fiduciary duty that they needed to fulfill, and they failed miserably. And we saw in the previous video, this part here, they said the database server cannot recognize the primary and the backup disk. Okay, so that led me to believe that they had some sort of a redundant drive set up, either RAID or mirrored logical volume or something, and that maybe the file system on one disk got corrupted and it replicated over to the other disk. And of course, then they said they transferred the drives, the disks, plural, to a special recovery company, and no update from the company. Now let me refresh this because there is an update. Okay, and down here it says, it is regret that we inform you that after the diagnostics performed by our engineers, we have found the damage to be too severe, deeming this case unrecoverable. And it says the SSD, the solid state drive, so they use the solid state drive, doesn't detect because of a failed controller chip. There's no support for this controller model in the data recovery industry. So that tells me that when they said disks up here, they were not being truthful, because apparently they only had one disk, one solid state drive, and it looked like maybe they were using some sort of an off-brand, cheap brand drive instead of a brand name drive, because I would think that if they were using a brand name drive like Western Digital or Seagate or Samsung or maybe Hitachi, there would probably be support for that controller in the data recovery industry, right? But there's not. So anyway, Express Crypto is now completely down. They're out of business, and apparently they still have the cryptocurrency, but they started the liquidation process, and so they just had people fill out a form saying, hey, give us the best estimate of what you had here. No way to prove what they had. They have no way of proving what we had. So I don't know how that's going to work. But anyway, the point I'm trying to make here is that because they did not have any type of backup at all, apparently they did not even have a redundant drive system, no backup drive, not performing any file level backups or anything. They're out of business. So I'm just saying, this is why it's important to have a good backup system. That includes both redundant drives and file level backups as well. And we'll talk more about file level backups later. But for right now, let's just talk about the redundant drive setup. All right. So anyway, in this video, of course, we're going to continue on talking about that as it pertains to RAID. Now, there are lots of different RAID arrays, RAID configurations that you can use. Some of them provide data redundancy, some do not. With RAID 0, it's just a stripe type of system, which provides faster throughput, or faster writes, I should say, because reads are a bit slower with it, and no redundancy. So we're not going to use that for our data safety, right? And we also have RAID 1, which is mirrored. And it provides data redundancy. And then we have RAID 5, striped with parity. And I'm not going to say this offers redundancy, but this does offers a recovery if the drive fails. And we have RAID 6. Which is like RAID 5, except it offers recovery if 2 drives fail. Okay, and then we have others as well. There is RAID 2, 3, and 4, but they're not commonly used. And then we have also like RAID 01 and RAID 10, which are both hybrids between the striping and mirrored. Okay, so anyway, let's take a look at the RAID 0 first. Even though it's not a redundancy one, we'll take a look at it anyway. So with RAID 0, remember I said it was striped. And this makes for faster writes. Okay, so the way it happens here, the way it works, is that when the computer goes to do a write operation with RAID 0, it will put a stripe there on that drive, and a stripe on that drive, and a stripe on that drive, and a stripe on that drive. So no one drive holds all of your data. Okay, the data are spread all across all of the drives in a RAID 0 array. And as I said, that's just to make the write throughput faster. So, that might be good for like busy servers, like busy database servers, busy web servers, for example, right? So it can speed things up considerably. Now, all these drives also, the storage capacity is cumulative. Okay, and that just means that, let's say we have a 1 terabyte drive. Well, just to make things simple, I know 1 terabyte is pretty small by modern standards, but let's say that these 4 drives are all 1 terabyte drives. Okay, so the storage capacity is cumulative, so these 4 1 terabyte drives give you a total of 4 terabytes of storage. Okay, so you just add up all of the storage capacity of all the drives, and you're good, okay? But problem is, if one of these drives fails, guess what? You lose the entire RAID array. You lose all of the data on the entire array, okay? So if you're using RAID 0, you definitely want to have a file level backup solution. Well, you want that anyway, but it's especially important with RAID 0. Okay? So let's go ahead here and put this back in. Now, RAID 1 is different. RAID 1 is your mirrored setup. Okay, and with RAID 1, you have to have at least 2 drives. And that was true with the striped as well. Okay, and the storage capacity is not cumulative. Okay, so what I mean by that is that each drive is an exact replica of every other drive in the system, right? So when you do a write operation, it actually can be slowed down a bit with RAID 1 because you're having to write to each one of these drives. And if you have like 4 1 terabyte drives, in this case, let's say, you don't have 4 terabytes of storage. You only have 1 terabyte of storage because each one of these drives is a replica of all of the other drives. So if you lose one of these drives, if you lose any of these drives, the other drives in the system will just keep on running until you can replace that failed drive. And which is really cool, right? Now, there is the problem, of course, of what happens if the file system gets corrupted, and which sometimes happens. So if you have a corrupted file system, there's on one drive, there's a possibility that it could replicate over to all the other drives as well, and then you'd still have nothing. So again, you still want to have a file level backup system even with the RAID 1. Now, the next one is RAID 5. And this is striped with parity. And for RAID 5, you have to have at least 3 drives. And the storage capacity is nearly cumulative. Okay, so what do I mean by that? Well, with RAID 5, yeah, it's striping, just like RAID 0. So whenever you do a write operation, go to stripe there, a stripe there, a stripe there, and a stripe there to speed up the write operation. But you also have parity data. So you have the RAID then, the RAID controllers or the RAID software, as the case may be, will calculate parity data every time a write is done. And the parity data on RAID 5 will be spread across all of these disks. And the parity data will occupy the equivalent of the capacity of one of these disks. So in this case, we have 4 1 terabyte drives, but we only have 3 terabytes of storage because 1 terabyte is taken up by the parity data. And and also if we had, for example, instead if we had 4 2 terabyte drives, then we would lose 2 terabytes of storage to the parity data. Now what happens is when one of these drives dies, let's say it's this one this time, let's say that one goes bad, it just quits working, you're going to be missing part of the data, okay? Just the same as you would if you had lost a drive in a RAID 0 setup. Now the difference is that these other 3 drives still have the parity data. And so they can still keep on going with reduced performance because they can rebuild the data from that bad drive using the parity data. And then when you stick another drive back in, so we've replaced our bad drive with a new drive, it is going to rebuild the data that was missing from that bad drive, just from the parity data. Now, there are some disadvantages here, and a little bit of controversy here about this because back in the day, when RAID was first invented, the drives were not a large capacity. So it didn't take all that long to rebuild the data on a new drive. Nowadays, though, drives are very, very large capacity, and it takes a long time to rebuild the data on a new drive once you stick it in. And because of that, and the fact that RAID 5 can only tolerate 1 bad drive at a time, there's a good possibility that during the time that this drive is rebuilding, and depending on the size of the drive, it could take hours, it could take days, to rebuild. But during that rebuild process, there is the possibility that another drive could fail, which again would mean the loss of the entire RAID array. It would be the loss of all of your data. So, because of that, somebody invented RAID 6. And RAID 6, you need at least 4 drives. And RAID 6 can stand losing up to 2 drives at a time. So with RAID 6, you could have 1 drive go bad, you stick a new drive in, and if another drive goes bad before the first drive rebuilds, then you can still recover, okay? These 2 remaining, oops, didn't mean to do that. These 2 remaining drives can still handle the load, albeit with reduced performance. Now, with RAID 6, you lose the equivalent of 2 drives worth of capacity to the parity data. So in this case, if we have 4 1 terabyte drives, you end up losing 2 terabytes worth of data, and you end up with only 2 terabytes worth of actual storage space. But regardless, I mean, it might be worth it because, again, there is the possibility that a second drive could fail when the first drive is rebuilding. So you need to keep that in mind. And if you're having to choose between RAID 5 and RAID 6, okay. Now, something else here I forgot to look up. Let's do that right now. Someday I'll get around to setting DuckDuckGo as my default search engine in Firefox. Just haven't done that. But anyway, let's do this. RAID drives. Okay. And what I want to show you here that RAID arrays are not just for servers in the enterprise market. They can also be used at home, and well, even in the enterprise, you don't necessarily have to have the RAID arrays in the actual servers. So you can actually have like these devices here, and you can get one of these and get out of here. There we go. And you can get ones that you can either hook up to your own personal computer as an accessory, just hook it up to the USB port, or you can get ones that will hook up to the network. So you can like plug one into a network switch and then have it available for all of the computers on your system. And so they're really cool, and some of them are, fairly affordable, for home use. And you can also get ones that are very expensive, for use in the enterprise. So that's really cool. And you don't have to mess around then with any configurations on your computer or on your software or anything like that. It's just, basically it's, for the most part, it's just plug and play, right? So, which is really cool. And the other thing here, I forgot to show you. I should have shown you this before I showed you that. But anyway, getting back to servers and the RAID arrays that you put inside of your servers or inside of your computers, they're basically 2 types. We got hardware and software. So hardware RAID arrays are run off a RAID controller of some sort. Now, back in the old days, we used to have actual plug-in RAID controller cards that would plug into an expansion slot on your computer or into your server. And nowadays, though, you're generally going to find the hardware RAID is built into the chipset of your computer's motherboard. There is an advantage to that. What you do, or what you can do, is when you set up your computer, when you set up your server, okay, you will go into some sort of a BIOS or firmware-based setup utility and just configure the RAID array there. And then when you go to install the operating system, you have that RAID array already available to you. Just go ahead and you can configure the installer, to recognize the RAID array just as its own drive unit, so to speak. And you can, for example, put the home directory on the RAID array. If you're running a database server, the databases like MySQL and MariaDB, store their database files in the var directory. Maybe you want to put the var directory on the RAID array. Lots of possibilities, lots of things you can do. If your machine does not have a hardware RAID controller, you can always use software RAID. Software RAID is built into Linux and Windows Server, maybe others as well, maybe BSD, Unix, I don't know. I don't know about all of them. But I know for sure you can have software RAID capabilities with Linux and Windows Server, right? But anyway, the big advantage, of course, is that you don't have to have a hardware RAID controller. The slight disadvantage is that you won't be able to set it up during the installation of your operating system. You have to install the operating system first, then set up your software RAID array, and then manually move your partitions over to that RAID array. Okay, so yeah. Anyway, I think that's pretty much it. And the hardware RAID array, it's kind of hard for me to demonstrate because I would have to basically fire up one of my old servers, and film the process with a camera. And the other thing about it too is that it might not do you any good for me to show you that anyway, because the setup utilities on every server is different, and all of the servers I have in the house are so old that they're probably not going to be like anything that you'd see today anyhow. Software RAID, on the other hand, I can demo that, and I'm going to do that in an upcoming video. So anyway, I think that's pretty much it for that. The only other thing I want to say is that this video is brought to you by my sponsor, which is me, and my books. Books plural now, yeah. The first one, Mastering Linux Security and Hardening. And if you're serious about making sure that your servers are up to snuff security-wise, hey, this book can help you out, all right? And also my brand new book, Linux Service Management Made Easy with Systemd. And this book is the first of its kind. No other book in human history has ever been written that covers the Systemd ecosystem in depth. Okay, the only other books you'll find that even have Systemd in the title, they're really more general purpose administration books, and they only cover the bare basics of Systemd. Now, this book, we cover it in detail, so you will get a good view, a good overview, good hands-on practice with the entire Systemd ecosystem. Okay, so anyway, having said that, I think it's about it. Be sure to like the video and subscribe to the channel. That helps get the video out to more viewers, helps it to show up in their feeds, and even share it out, right? But anyway, that's pretty much it. I thank you for watching, and we'll see you next time.